length is a piece of the circumference. So just understand that, and you'll be fine. Today is the 20th. So imagine every circle has a circumference, and arc length is just a piece of that, a fraction of that, okay? So for example, if you had a circumference of, say, 30 feet, half of that would be 15, right? It'd be a semicircle. That's an arc length, okay? That's all arc length means. It's a piece of the circumference of a circle. So we're going to go over a formula for arc length. We're going to do some examples. The first two examples are going to cover the front part of your worksheet. The last two examples are going to cover the back. If you read the directions on the front, it says round to the nearest tenth. So basically it's calculator work. On the back, you're going to just leave it as a fraction. Okay. So first of all, who remembers the formula for circumference? Yeah, there you go. Okay, exactly. For this worksheet, we're going to be using the radius formula, so it's going to be 2 pi r. That's going to give you the whole length of the circumference. Now the question becomes, let's say we just wanted to figure out from here to, say, there. You can pick any piece of the circle. It doesn't have to be that big. How do you figure out how big that is? Well, you have to know another piece of information, mainly the angle that forms that piece of the circle. Now, for simplicity's sake, let's say this angle is 90 degrees. Okay? And I want to figure out the length of this. Okay, this is an arc. It's a piece of the circle. How would I figure out how big that is? Can anybody tell me what fraction of the circle that would be if that's 90 degrees? There you go. It would be 1/4 because the circle is 360, right? So you would actually take 1/4 of the circumference. Now there's one more piece of information you need. You need to know how big that radius is. Otherwise you can't figure out how big the circumference is. So again, just for the sake of simplicity, let's just say that the radius is 1 foot. Okay, we'll just say 1 foot. So to figure that out, first of all, you'd figure out the circumference. It'd be 2 pi times 1, which would just be 2 pi. And then someone said it'd be 1/4 of that. So we would take that number and multiply by 1/4. Okay, so what have we done? We found the circumference, and then we figured out what portion of that circumference, the 1/4. So now I'm going to give you what the formula is going to look like. I'm going to break it down for you. We're going to use the letter L for arc length. Okay. The first part of the formula I will explain. Theta over 360. That will give you that fraction of the circumference. So how he figured that out was he plugged in 90 for theta, and he got 90 over 360 gives you 1/4. So whatever your angle is, if you divide by 360, that will give you the percentage of the circle. So imagine if it was 360, then you get 1 back, right? If you plugged in 360 for theta. If theta was, say, 180, you would get 1/2. Okay? So all you have to do is plug in the angle, and that will give you the fraction of the circle you're talking about. The second part of the arc length formula is the circumference. Okay? So you just be multiplying that by 2 pi r. So if you take the fraction of the circle and multiply it by the circumference, it will give you the length of that arc. So it is a kind of complicated formula, but if you think of it in those two ways, the first part being the fraction and the second part being the circumference, then you can see the arc length is just the fraction of the circumference. So we're going to, like I said, we're going to do 2 examples that will cover questions from the front, and then I'll let you guys work for a little bit, and then we'll cover 2 examples that will be more like the back, even though they're very similar.